Hello, my name is Ron Arroyo, and I'm going to be teaching you the Pythagorean Theorem. Now, if I can get this to work, what the Pythagorean Theorem states is that a squared plus b squared equals c squared. Now, before we get into what this equation means, let's draw ourselves a right triangle. And mark it, right triangle. And let's put in some sides. Let's say 4 and 5. Now we're going to label these sides. This is going to be C because this is the hypotenuse. This side right here, opposite of the right angle, is called the hypotenuse. These two sides can either be A or B. It doesn't really matter which one they are. But for the sake of this tutorial, we're going to make this one, smallest one, A, and the second largest one, we're going to make it B. So now that we have A, B, and C, let's start explaining what this equation here means. So let's take A, which is 3, and we're going to square it. So 3 squared plus B, which is 4. I'm going to square it, equals C, which is 5. And again, we're going to square it. Now, as you can see, the order of B and A doesn't really matter, because you could also have it as 4 squared plus 3 squared is equal to 5 squared. Same result. So, let's solve this equation. 3 squared equals 9, plus 4 squared, 16, equals 25 squared. 25. Sorry about that. Let's add 9 and 16, which equals 25, which is equal to 5 squared, which is 25. So this Pythagorean theorem works. But it only works with right angles. So let's try another one. And let's make this triangle a lot theoretically bigger. Remember, these triangles are not to proportion or to size. Now let's make this side 18 and 24 and x. Now these numbers are a lot bigger, but don't be afraid. We're going to tackle them together. So let's write the equation. A squared plus B squared equals C squared. Sorry about my bad. 2 there. I don't know if that looks like a 2. That's better. Okay, A squared plus B squared equals C squared. Now we know x is C, and these two can either be A or B. And for the sake of the tutorial, we're going to make this A, make this B, and let's write a new equation. 18 squared plus B squared, which is 24, equals C squared, which is x. So now 18 squared is 324 plus 24 squared, 576. Feel free to check my math. Equals x squared. Now, let's add 324 with 576. 4 and 6 equal 10. Carry the 1. 1 plus 2 equals 3, plus 7 equals 10, carry the 1. 1 plus 3 plus 5 equals 9. So now we have a really big number, 900. And let me, first of all, switch this. So that x squared equals 900. Now I only knew this because it is a lot nicer if the x, the variable, is on the left-hand side when you're solving a problem like this. So in case you didn't know, x equals 30. And now you're wondering, wait, how'd you get from here to here? Well, let's go over here. X squared equals 900. What you're going to do is square root both sides, and a square and a root are going to cancel themselves off, so you're left with x. And you need to find square root of 900, which is 30, something you should just know. And that's how you got it. So now we know the answer, x equals 30. And we can go plug it in. Okay, there you have it. This side is 18, this side is 24, and 30. And this checks out. So now, this turned out to be a very nice number, 900. And it had a very nice root, 30, which is, these are all very nice numbers. So let's try one that is not so nice, very mean. In fact, let's try. And we'll be working with smaller numbers. Let's say 5 and 7. The right angle. So now that we have these numbers here, let's write our equation. A squared plus b squared equals c squared. Oh, I forgot this x. But we know this x is c. These two can either be a or b. Doesn't really matter, but I'm going to make this a. I'll make this b. So we have 5 squared plus 7 squared equals x squared. And 5 squared is 25. Plus 7 squared is 49 equals x squared. So 25 plus 49, 74. And then again, I'm going to switch them sides just so it looks a little bit nicer in the end. So now here you notice that 74 isn't a perfect square root. I mean, it's a square. So let's go over here. You got x squared equals 74, and you're gonna square root these. Well, this and this cancel out, so you're left with x equals 74. And 74 isn't a perfect square. So we're going to prime factorization, prime factorize, or this, 2 times. And now we're going to divide 74 by 2, which would be 37. And I believe that is it. 37, by my calculations, does not go into any other. So 37 is a prime, 2 is a prime. So we leave it as this. This is our answer right here. So we go back on top. And x is now root of 74. That is our answer. Sometimes you can write it nicer, but as you can see, these are very ugly numbers. Not very nice at all, very mean. So let's go back here. Why were these so nice? Well, let's see something here. If you take the smallest one and divide it by 3, what do you get? You get 6. And so let's take 24 and divide that by 4, and you get 6. You get 30, and you divide that by 5, and you get 6. And you're saying, wait a minute, you're just finding a number so that the product or the quotient will be 6. But if you notice these numbers 3, 4, and 5, they are our original right triangle that we did on the front page, the first page, if you can remember. 3, 4, and 5. And what's going on is that you just took this right triangle and you made it bigger. You expanded it by 6. You made it bigger by 6. And what this means is that these are all going to be very nice numbers. So 30 divided by 6, which is what you multiplied, will be 5. 24 divided by 6 will be 4, and 18 divided by 6 will be 3. Now you're asking, well, okay, so what now? How does this help us? What is the use of this? And I'm going to show you one, because I learned a very neat trick when I discovered this. I learned that you can make things a lot simpler. So let's get a new page here, and whoops, and let's draw ourselves a right triangle. So we got this right triangle, and we're going to use the same numbers over here as the ones we used here: 18, 24, and 30. So we got 18, 24, and the right triangle. So now, instead of writing our equation, a squared plus b squared equals whatever. Now, I'm going to show you a neat little trick. You're going to take 18 and you're going to divide it by 3. You divide by 3 because there are 3 sides. And that's going to be 6. And you're like, well, you already said that on the last page. So we're going to take this 3, we're going to bring it all the way over to 24, and we're going to add it to 24. And so now you have 24 plus 6 equals 30. And as you'll notice, 30 is the missing side, which is correct. Now, how does this work, you're asking? And I will answer, I said. So this is the equation I made up. Well, I didn't really make it up. I'm sure that it's out there. But I found it by myself. So now, we're going to have, assuming that this is C, we all know it's C, assuming that this is 18 is A, and 24 is B, let's write this equation, where B plus parentheses A divided by 3 will equal C. And this new equation is not so hard if you look at it. So let's see. Oops. Oops. Whoa, whoa, whoa. Let's get up here. Now, let's go back. So you've got B plus A divided by 3 equals C. So let's plug in the numbers. B equals 24 plus A equals 18 divided by 3 parentheses equals C. Now we already did this. We know 24 plus 6, was it? Yeah, equals 30. And that's correct. So, as you can see, this is a lot simpler. This is all the work we did for that. It is a lot simpler than this mess that we have here. You can barely tell what we're doing. It's hard. And so this is a lot simpler once you understand that this is just a bigger 3, 4, 5 triangle. Once you understand this, it's a lot simpler. Now, this only works when the triangle is similar to similar to this 3, 4, 5 triangle. The triangle is nice. What I mean by nice is that it's similar to 3, 4, 5. It's got the same angles, and the sides are proportional. So it's proportional, it's similar, and it only works if it's similar to 3, 4, 5. Here, in this problem, it would not work at all. It would just be a mess, you'd get confused, and you'd probably get the wrong answer. So it is a lot simpler if you only use it for a triangle that is similar to 3, 4, 5. It's a lot simpler than this. But you have to understand that it doesn't work on all right triangles, so that's why I would not always recommend using it. Now, let's develop our skills with this. And that was my alarm. I'm sorry about that. I might just cut that out. So let's triangle. And now you have x here. You've got, let's say, 40 here. And you've got 24 here. And you need to find x. So you use the same equation, a squared plus b squared equals c squared. And when you use it, try and plug in the numbers. So you can see this is either a or b. So let's plug in the numbers. I'll use x as a. So x will now be a. So it's x squared plus 24 squared equals 40 squared. And what you're going to do is figure out these squares, which I believe here was 576, and 40 would be 1,600 plus x squared. And so now you've got yourself an equation, and algebra takes over, and this is actually very simple. Minus 576 equals minus 576. Now x squared will equal, that 6 minus 10 is 4. That turns into a 9. So let's make this 10, 9. That's 2, 1, and 1. And x equals 1,124. Oh, I'm sorry. X squared equals 124. Yeah. and we do x root it equals 124. X equals root 124. And you just figure this out, which will be x equals 32. That's your answer. And you can do this with the same thing. Sorry about that. Let's just grab a new page. You have this right angle. You can do that with x. 30. And whatever this is, I forgot. Let's make that 61. You can find x. Now this is going to be really ugly and mean. But you can figure it out in the end using the Pythagorean Theorem. Alright. I'll see you later, and as always, thanks for watching.